The launch team will continue to monitor the situation and will coordinate a new T0 based on the weather clear.
LC ATC3 on 1.
Go ahead.
Flight sluice complete. Pressure is being adjusted to 3,800.
Roger. HYE, LC.
HYE, go ahead.
Roger. Verify hydraulic pressures and band for pre-TPA spin limits to on.
That is verified.
Roger. TM1, pre-TPA spin limits on.
Roger.
As I mentioned earlier, we have a total of 65 minutes windows of time available today to launch the AFSPC4 mission. Currently, we have 60 minutes of the window remaining. Launch windows are unique to each mission and are determined by satellite's intended orbit, and when that orbital plane will intersect with the rocket's trajectory or path. Many additional factors help determine the launch window for a particular mission, including the performance or capability of the launch vehicle. Rockets with more capability or power sometimes enable longer windows, which gives the launch team more flexibility to fix any last-minute technical issues or wait out severe weather. Windows also vary by day, month, and year based on the satellite's desired orbit. A mission's trajectory and orbit are developed by the mission design team that considers all of these factors as they plan the satellite's trip to space.
Launch Director, LC, Channel 1.
LDN 1.
Roger, sir. Flight slews are complete, including other subsequent tasks. So at this time, we're essentially in a L-9 minute in holding configuration.
Roger that.
MEQ, LC.
Go.
Roger, since we're anticipating probably a delay here of approximately 30 additional minutes, please reestablish has-gas scan pattern 120.
Roger.
This is Delta Mission Control at T-minus 4 minutes and holding. We have now lifted the flight through precipitation weather violation, but continue to violate the surface electric fields rule, the cumulus clouds rule, the lightning rule, and the anvil clouds rule. So we will continue to monitor, and the team will establish a new T0 based on the weather clearing. This is Delta Mission Control at T-minus 4 minutes and holding. There are approximately 45 minutes remaining in tonight's window. The surface electric field rule violation has now been lifted, but we continue to violate the cumulus cloud rule, the lightning rule, and the anvil cloud rule. At this point, we expect that we will establish a new T0 no earlier than 7:22 p.m. Eastern Time.
LCRC on 1.
Go ahead.
Roger. I can report that, particularly for the long pole, we're expecting the lightning rule to clear by 23:22. Additionally, phase 1s for all Cape KSC have been terminated.
Roger.
This is Delta Mission Control at T-minus 4 minutes and holding. We've just heard that the cumulus cloud rule has now lifted. We do remain red on the lightning rule and the attached anvil cloud rule, so we will continue to monitor those and hope that the rules will lift and we'll be able to establish a new T0 this evening.
LC, this LD on channel 1.
Go ahead.
LC, at this time, please coordinate a new T0 for 23:28:00 Zulu. We expect the last red LCC for weather to clear at 23:22 Zulu, so that we expect that to come in after your poll but before the T-4 and counting pickup. If you did not receive that prior, we will not pick up the count with the red range. Red
Copy
weather.
that. Copy. RC, LC.
RCN1.
Roger, please coordinate a new T0 of 23:28 Zulu.
Roger and work.
Timer, LC.
Go.
Roger, please set the sequencer for a new T0 of 23:28 Zulu.
Copy. 23:28 Zulu.
ALC, hold fire off.
Off.
As you've just heard, the launch team does expect that the weather conditions are going to lift, and a new T0 is being established for 7:28 p.m. Eastern Time.
LC timer.
Go ahead.
The new T0 of 23:28 has been established.
Roger.
LC, MEQ on 1.
Go MEQ.
Yes, sir. Do you want the has gas pattern to set to 140?
We'll pick that up at L 12 minutes, or we'll pick back up in our script for setting the master script.
Copy.
LCRC on 1.
Go.
Roger, we have a launch window management plan time of 23:48. End of window.
Roger.
This is Delta Mission Control at T-minus 4 minutes and holding. In approximately 10 minutes, we will hear launch conductor Doug LeBeau poll his team for their final go to resume the launch countdown in preparation for a 7:28 p.m. launch.
L minus 12 minutes.
MEQ, LC.
Go.
This is
Establish
Delta
HAZGAS
Mission
scan.
Control at T-minus 4 minutes and holding. We are now just 5 minutes away from the final terminal count poll where the team will give their final go to resume the Delta IV launch countdown. We continue to violate the Anvil cloud rule and the lightning rule, but we do expect that these rules will lift in time to support a 7:28 p.m. T0.
Roger.
L minus 10 minutes.
RC, verify solar radiation limits acceptable for launch.
Verified.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
This is Delta Mission Control at T-minus 4 minutes and holding. The attached Anvil cloud rule has cleared, so we are now only violating the lightning rule, which we expect to clear before the 7:28 p.m. planned T0.
All steps are complete prior to the terminal count status check.
L minus 9 minutes.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned built-in hold as preparations for the launch continue. Launch conductor Doug LeBeau will poll the team in a few moments for their final go to resume the Delta IV launch countdown. 31 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Delta vehicle systems, ground systems, payload, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Final processing steps just prior to launch include completing propellant topping of both vehicle stages, securing propellant tanks, and pressurizing tanks to flight pressures. Let's listen as Doug LeBeau conducts the final polling of the launch team.
L minus 7 minutes.
Status check to proceed with terminal count. MEQ,
Go.
MEA,
Go.
HYE,
Go.
LOX 1,
Go.
LOX 2,
Go.
VP,
Go.
PNE,
Go.
BP,
Go.
ATC 1,
Go.
PEA,
Go.
Fuel 1,
Go.
Fuel 2,
Go.
TM 1,
Go.
ATC 3,
Go.
TM 2,
Go.
FMA,
Go.
VE,
Go.
EEA,
Go.
GE,
Go.
SYS,
Go.
DSC,
Go.
Timer,
Go.
ECS,
Go.
QE,
Go.
USO,
Go.
OSM,
Go.
VSE,
Go.
ALC,
Go.
AC,
AC is go.
RC.
No go due to weather LCC violations. We'll update when green.
Roger, advise when clear to proceed.
Roger.
LD,
LC, the launch vehicle is ready to launch pending acceptable weather, estimated to clear at 2322 Zulu, which will come in from the RC. I will not be coming back to you with another response.
Roger. MD, Mission Director, Channel 1.
This is the MD on 1. You have permission to launch pending a weather go from the RC. You will not hear my voice again.
Roger. Proceeding with the count.
LCRC on 1.
Go ahead.
Roger that. Range weather is go. Weather is clear.
Roger, have a clear to proceed.
Clear to proceed.
MEQ, establish swing arm lock pins, pull.
Polling is complete, and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, the team will enter the terminal count and will begin securing the second stage liquid oxygen tank. At T-minus 332, CBC liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant fill and drain valves. Also at T-minus 332, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3, the vehicle ordnance system will be armed, and the CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized, as well as confirm CBC, DCSS, and FTS battery voltages. At T-minus 120, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the eastern range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. At T-minus 15 seconds, the ROFIs or sparklers are ignited to burn off excess hydrogen at the base of the vehicle. Liftoff will occur at T-minus 0.
T-minus 4 minutes and counting.
Upper stage lock securing started.
Vehicle transferring
The
internal.
countdown clock has resumed, and we are go for launch at 7:28 p.m. Eastern Time.
Three minutes, 32 seconds.
CPC propellant tank securing started.
Vehicle transfer internal complete.
Second stage secure at flight level.
Three minutes, 14 seconds.
CBC pre-press started.
3 minutes, 10.
CBC lock secured.
Spacecraft to internal.
Spacecraft going internal.
Angels going internal.
3 minutes.
Vehicle ordnance arming. CBC locks at flight pressure and flight level. Vehicle ordnance armed.
T-minus 2 minutes, 30 seconds and counting. The countdown is on track as we proceed toward T0.
Two minutes, 10 seconds.
Verify spacecraft internal.
Spacecraft internal.
Angels internal.
2 minutes.
GPA script running.
Hydraulic press at 4,000.
CBC LH2 at flight pressure and flight level.
One minute, 30 seconds.
T-minus 90 seconds, and the launch vehicle, payload, ground systems, and Eastern Range are go for launch.
1 minute, 20.
Upper stage LH2 securing started.
One minute.
T-minus 1 minute and counting.
Engine start box go.
Rock, report range status.
Range green.
50 seconds. 45.
Launch enable. GE main power off.
Main power off.
Upper stage LH2 secure at flight level.
$30.
Status check.
Go Delta.
Go AFSPC4. Green board.
25.
Flight lock in.
23.
SRM TVC blowdown.
15.
Rove ignition.
T-minus 10, 9, 8, 7, 6, 5. We have ignition of the RS-68 engine. 2, 1. We have liftoff of the United Launch Alliance Delta IV rocket carrying the AFSPC4 mission for the United States Air Force.
Good chamber pressure on the main engine.
You're hearing the voice of Steve Agate providing launch vehicle ascent data.
Good symmetrical burn. 17 seconds in. "25 seconds in, still looking good. Good engine control on the first stage. Passing 35 seconds, chamber pressure beginning to drop in the solids as expected. 40 seconds in. Good chamber pressure in the main engine. Coming up 47 seconds. Mark 47 seconds, Mach 1. Vehicle now going transonic. Altitude now passing 5 nautical miles, coming up on 1 minute. Mark 60 seconds in, max Q, maximum dynamic pressure in the vehicle. Downrange distance about 4.5 nautical miles. 1 minute, 12 seconds in. Still looking good. Just had the hydrazine supply valve open in the second stage. On time, 1 minute, 23 seconds, about 10 seconds now remaining in the solids. Standing by for solid rocket motor burnout. Burnout. Standing by for SEP. And separation. Solid rocket motors have successfully separated from the vehicle. 1 minute, 50 seconds in. 1 minute, 56 seconds in. The Delta IV rocket now only weighs 1/2 of what it did at launch, burning propellant at the rate of 1,856 pounds per second. 2 minutes, 5 seconds in. Altitude now 26 nautical miles, velocity 5,753 feet per second, downrange distance 28.4 nautical miles. Now passing 2 minutes, 20 seconds, Mach 5, 5 times the speed of sound is our velocity at this point. Chamber pressure holding very well in the first stage. Good engine control in the first stage. About 1.5 minutes remaining in first stage flight. Altitude now passing 40 nautical miles. Two minutes, 53 seconds in. This time we're experiencing the maximum fairing skin temperature as the vehicle continues to ascend. Passing the 3-minute mark. Mark 3 minutes, 2 seconds in, altitude now 46.5 nautical miles, velocity 10,275 feet per second, downrange distance 88.9 nautical miles. Less than 1 minute remaining in first stage flight. 3 minutes, 20 seconds in. Chamber pressure holding very well on the first stage, good engine control. 3 minutes, 30 seconds in, about 30 seconds remaining in first stage flight. We'll first have the command to go to the partial thrust mode about 25 seconds from now. We'll be in the partial thrust mode for just a few seconds prior to main engine cutoff or MECO. 3 minutes, 45 seconds in, standing by for the command to go to partial thrust mode about 10 seconds from now. And we have the partial thrust command. Chamber pressure dropping as expected in the first stage. Standing by for MECO. We have MECO. Standing by for stage separation. And we have stage separation. We have NEDS is deploying. Standing by for the igniter spark. We have igniter spark standing by for ignition. And we have ignition. Ignition on the second stage. Second stage chamber pressure is beginning to rise. Good chamber pressure on the second stage. Standing by for fairing SEP. And we have fairing SEP.
This is Delta Mission Control at T+5 minutes. We've just heard Steve Agad report the successful execution of the events comprising the early portion of this evening's flight. I'm joined now by Captain Dan Knapmiller from the Air Force Research Laboratory. Welcome, Captain Knapmiller.
Thanks, Danielle. It's an honor to be here for the liftoff of the AFSPC4 mission.
Captain Knapmiller, can you begin by telling us a little bit about where you work at the Air Force Research Laboratory and what this lab does for the Air Force?
Sure. I work at AFRL's Space Vehicles Directorate, located on Kirtland Air Force Base in Albuquerque, New Mexico. At Space Vehicles, we have 4 main capability focus areas. 1, space situational awareness. This is where Angels fits in, and it's exactly what it sounds like, knowing where any given object is in its orbit at any given time, as well as its purpose.
Wow.
2, defensive space control. This deals with keeping our valuable space assets safe. 3, space communications and precision navigation and timing. Think GPS here and or follow-on technologies to GPS and satellite communications. And 4, space intelligence, surveillance, and reconnaissance, or ISR. Our big picture vision is essentially to consistently push the envelope, illuminating the realm of the possible in terms of space technology, knowledge, and vision, while developing and providing unique options to our nation's space community. Our research also inherently benefits all peaceful users of space. For example, think about how the U.S. and really the global economy as a whole relies on our GPS system. Those satellites orbit in what is termed a medium Earth orbit, or MEO, approximately 12,000 miles above the Earth's surface, which is also one of the harshest areas in space in terms of radiation exposure. AFRL research has the hardened electronics that can survive in that type of environment.
Interesting.
Most GPS satellites have actually been operational several years past their design life, which is really a testament to how well they were designed.
Wow, that's great. Why is this research so important?
The Angels satellite is part of the Air Force Research Lab's Space Vehicles Directorate's work in space situational awareness and a small part of our overall mission to stay one step ahead in space. Essentially, we need to know what's in orbit, its purpose, and its intent. ANGELS, which stands for Automated Navigation and Guidance Experiment for Local Space, bit of a mouthful, is a science and technology project developing sensor and navigation technology, plus the honing of operational techniques, providing new ways to examine what is in geosynchronous orbit, otherwise known as GEO. Many of our military and key commercial communication satellites orbit in GEO, approximately 22,000 miles above the Earth's surface, making it difficult to discern the purpose of a given object from existing ground-based telescopes, for instance. And with space becoming more contested and congested, enhancing our situational awareness in GEO is increasingly crucial.
Absolutely. Can you describe the ANGELS mission in a little bit more detail?
Sure. ANGELS will evaluate techniques for surveying a limited area of space. In this case, immediately around the second stage of the Delta IV launch vehicle.
Right.
The test region will be several hundred kilometers above GEO orbit, beginning 50 kilometers away, and over the course of several months progressing to within several kilometers of the Delta IV launch vehicle rocket body. The mission team has devised a layered strategy of advanced technology, testing, mission planning, and mission operations discipline to maintain safety of flight.
And what would you say are the main goals of the ANGELS mission?
The purpose can be described in three broad areas. First, test new sensors and techniques for the detection, tracking, and characterization of space objects. Second, explore new navigation techniques and technology, such as advanced GPS algorithms and high-performance accelerometers. Third, hone man-in-the-loop automation experiments to evolve our ability to safely navigate within limited areas of space.
Okay.
The hope is that this research will advance technology, knowledge, and vision and allow us to transition what we learn to other U.S. military and civilian satellite developers.
Thank you, Captain Netmiller. Are there any final thoughts you'd like to share with our audience about AFRL or ANGELS?
I can't emphasize enough the safety aspects built into the mission. We're doing a series of small but technologically significant steps, and within each step, a full range of what-ifs are thought through and evaluated. That's the nature of all research, really. Small steps, discovery, testing, and evaluation as we increase our technological capability while also benefiting our nation's economy as a whole.
Wow.
For example, a large percentage of our annual expenditures are focused on small businesses and investing to give us a comparative advantage in space through new scientific discoveries and commercial applications.
Great. And how about for you personally?
For me, working at AFRL's Space Vehicles Direct Hit gives me the opportunity to see impactful technology ranging from space weather prediction to novel sensors to groundbreaking satellite electronics and systems to the future of space situational awareness. And it's a bit like Star Trek come to life, and everyone loves Star Trek, of course. I have no doubt that we are indeed laying the groundwork to guide us through the next century of space technology.
Wow. Thank you so much for joining us this evening to share your insights on the ANGELS mission. It was an honor to have you here for this important liftoff.
My pleasure, Danielle.
I'd also like to thank Steve Agad for his contributions to this evening's broadcast. For more information on the Delta IV launch vehicle, please visit www.ulalaunch.com. We'll conclude our coverage with another look at the successful liftoff of the Delta IV rocket carrying AFSPC4 for the United States Air Force. I'm Danielle Taylor, and on behalf of the entire launch team, thank you for joining us and have a wonderful evening. T-minus 10, 9, 8, 7, 6, 5. We have ignition of the RS-68 engine. 2, 1. We have liftoff of the United Launch Alliance Delta IV rocket carrying the AFSPC4 mission for the United States Air Force.
Good chamber pressure on the main engine.
You're hearing the voice of Steve Agad providing launch vehicle ascent data.
Good symmetrical burn. 17 seconds in. 25 seconds in. Still looking good. Good engine control on the first stage.